Good afternoon, everyone. This is Lynn Katz-Cherry with the Great Lakes Green Chemistry Network, and I'm here today with Clinton Boyd from the Michigan Green Chemistry Clearinghouse. And we want to welcome you to our monthly webinar. This month we have Cradle to Cradle Certification, what it is today and how it inspires companies to create safe and healthy products and processes. And we're extremely fortunate to have Stacy Glass as our presenter. She is, we had originally scheduled Bridget Luther, as you all know, and she was unable to make it, and we're very fortunate that she's been a great representative in her place. Stacy is an executive in residence at the Cradle to Cradle Innovation Institute, and I'll say a little bit more about that in a moment. Well, as I said, we're very fortunate to have today Stacy Glass from the Cradle to Cradle Innovation Institute. She's going to tell you about the Institute, but just let me say that the Institute was created to bring about a new industrial revolution that turns the making of things into a positive force for society, economy, and the planet. The the Institute administers the publicly available Cradle to Cradle Certified CM Product Standard, which is a continuous improvement quality standard gifted to the Institute by William McDonough and Michael Braungart after 18 years of development with the world's leading brands. I think many of you are familiar with the Cradle to Cradle concept, and we were particularly interested to have that in the context of the life cycle analysis to present that to our audience who's interested in green chemistry. Stacy herself is the executive in residence at the Cradle to Cradle Products Innovation Institute, advancing, and she is the co-author of Understanding Green Building Materials. She regularly presents to architects and students on the topics of sustainability and healthy building materials, and serves on the board of her local U.S. Green Building Council. She co-founded and was president of a building materials company, and she has an MBA from Duke University. So welcome today, Stacy. We're so pleased to have you, and I will now turn it over to you.
Lynn, thank you so much for that great introduction, and thank you all for having me today. What I want to do is, some of you may be familiar with Cradle to Cradle, and if you are, a lot has changed in the last 2 years. So we want to give you an update on that. If you're not familiar, we want to introduce you to Cradle and hopefully inspire you to learn more. So what I'm going to do today is provide an update on the protocol and on the Institute. I'll provide an overview of the certification program so you can get a sense for the overall. But then I'm really going to dig deep into the material health assessment methodology, which deals with chemistry. I thought that would be most relevant to this group. If there's time, then I'll go into the other 4 attributes in a little more detail. If not, I'll provide my slides as a follow-up and with links to more information. But I wanted to focus on what I think might be most relevant to you today, and we'll see how that goes. So some of you, as I mentioned, may be familiar with Cradle to Cradle, but let's just take a minute to put it in context and get on the same page. The Cradle to Cradle concept was given broad exposure when a book by William McDonough and Michael Braungart was published in 2002. It quickly became a practice and a design philosophy that can be applied at any level of design: communities, buildings, products, even economies, if you're familiar with some of the circular economy stuff that's going on in Europe right now. And it's become a quality standard through the Cradle to Cradle certification program. Cradle to Cradle philosophy imagines a world that is not resource constrained. We imagine a world where the concept of waste does not exist, where resources can be reused infinitely. We imagine a world where all materials are safe and healthy because they've been designed with the right ingredients. We imagine a world where carbon is no longer our primary concern because processes are powered with clean, renewable energy. This is a system where consumption is sustainable. So how do we achieve these ideals through design? Well, we emulate natural cycles. The Cradle to Cradle product framework first asks, what is a given product's function? Is it a resource for a natural system, like we're seeing on the left-hand side here, a biological nutrient? Or is it a resource for industry, like we're seeing on the right, a technical nutrient cycle? in the cradle-to-cradle world, everything is conceived of and designed to be a resource. Materials in this cycle need to be safe, healthy, and non-toxic to be reused continually. Also, when we emulate nature, we strive for this concept that we call eco-effectiveness. When we reduce and eliminate, we're moving towards zero, right? So this is the kind of reduction and elimination, the minimizing negative impacts on the bottom of the slide here, moving sort of towards zero. And that's like zero VOCs, net zero, zero waste. Our co-founder, Dr. Michael Braungart, makes the point that mankind strives to make a positive impact both economically and socially, but when it comes to the environment, we strive for zero. And zero is not a terribly inspiring goal. So Cradle to Cradle proposes that mankind can have a positive, restorative, beneficial impact on the environment. And so Cradle to Cradle certification is a program that provides manufacturers a path to apply these concepts to make safe, healthy, regenerative products. How did we get here? And Lynn did a nice job of giving a little bit of a history, so I'll go quickly through this. In 2002, as I mentioned, the book was published, and it inspired a lot of people. Bill and Michael, our founders, started working with companies to apply the cradle-to-cradle principles. In 2005, MBDC, their private consulting firm, first used this certification mark to denote achievement in cradle-to-cradle design. At the time, it was not intended to be an eco-label, but I don't know about you, it sure looked like one. Like, right, here's this certified mark on the back of a product. To me, I wanted to know, well, what is this saying about a product? Is this a good thing? And at the time, we couldn't, as consumers, as outside folks, didn't really know what it meant to be certified at different levels. We knew it came from a private consulting practice, and these things didn't make the label as useful as one might want. People really liked the idea of a multi-attribute label. Bill and Michael wanted to see this concept of a product design really realize its full potential. So in 2010, they founded the nonprofit Cradle to Cradle Products Innovation Institute. And then they gifted the protocol that they had developed to the Institute to now be the holder of that standard. So it took the Institute a few years to put the infrastructure in place to convene a certification, an independent certification standards board, and to start training more folks to be accredited assessors. All that really came together last year, and we were able to launch version 3 of the certification protocol, which is the first publicly available version of that standard that you can read all about it on the website. So, but hopefully today I'll give you enough of an overview that you'll have a sense for it. If you want to dig deeper into the protocol, it's available there for you. So let me tell you about the standard. Well, first, let me tell you why companies certify, why people sort of get in this mindset. And they certify for many different reasons. Some of the most often things that we hear are integration of this eco-effectiveness vision that can provide different a differentiation and enhancement of the brand, but I think what we're really saying there is that the platform can be used as a sustainability platform that radiates through the entire company, right? The principles that you're going to hear about are really a platform to apply any kind of sustainability things, not just a product certification. Also, it's external verification. As we know, that's becoming more and more important as consumers and specifiers are looking for valid information. And what this is really verifying is future use cycles, safety for humans and environmental health, and sustainable manufacturing processes. Also, expert evaluations about products, and sometimes this as much as moves towards certification as it is helping the company understand what's in the product and how they might design or redesign in a more positive way. It also provides a positive trajectory for optimization, and you'll see how the program proceeds through many different levels and continuous improvement. It also helps organizations characterize and mitigate potential environmental issues and risks. And of course, it's a third-party assessment that can help verify claims, and this is becoming more important for regulations, but also as more and more certifications are requiring, like LEED, verification of certain attributes, the certification can help with that well. This is just to kind of get you in the mindset of what kinds of brands are getting your products certified. Here's an example of those kinds of brands. So now let me tell you about the certification program. It's a multi-attribute approach that can be applied to any kind of product, consumer product, building materials, electronic goods, really anything. Where many certifications in the market address one aspect of a product or its production, the Cradle to Cradle product standard addresses 5 categories relating to human and environmental health. These evaluation criteria are based on Cradle to Cradle principles. The first is material health, and this is about making products out of materials that are safe and healthy for humans and the environment. The next is material reutilization, and this is about designing products so all materials can be reused by nature or industry, so designing for that appropriate metabolism. Then we have renewable energy and carbon management, and this is about assembling and manufacturing products with renewable, non-polluting energy. And what we're really doing here is changing the conversation about carbon footprint. If we're using renewable energy, that becomes much less of a concern for us. Water stewardship, making products in ways that protect and enrich water supplies, and social fairness, treating all people involved in the product manufacturing process in socially responsible ways. So those are the 5 categories. To begin the process, companies establish an intent to work towards cradle-to-cradle principles. And then they go through, and I'm using these as broad stages. First, an inventory stage. And this is about knowing. This is about understanding and creating a baseline. And that's creating an inventory in all 5 of those areas. So what is the chemical makeup of the product? What kind of energy is being drawn upon? How much is being used in the manufacture? Same with water. What are our social hotspots in our social responsibility? Where are we manufacturing and where are those social hotspots? Really taking an inventory and getting that knowing and understanding. And then they enter the assessment stage, and this is where they're comparing comparing where they're at to their goals or ideals and to cradle principles, and really understanding where they're at. And then they begin to work towards optimization. And of course, optimization usually starts with first minimizing those negative impacts, but then really working towards that positive impact. And this is creating plans, strategies, and infrastructure to optimize in all 5 of those categories. And then, of course, products are recertified every 2 years. So this process ends up being cyclical, although I've presented it in a very linear way. So this leads us to a very important part of the program, which is continuous improvement. We recognize that products are not perfect from a cradle-to-cradle perspective. Manufacturers are at different levels of optimization. The program allows manufacturers to enter the program at various levels and make a commitment to continuous improvement and optimization. Because this program is not based on a binary pass-fail model, but instead incorporates the concept of continuous improvement, the certification results are split into 5 levels, and that's basic, bronze, silver, gold, and platinum. Once a product's been certified, you'll see the final certification mark that's based on this scorecard. The product is certified at their lowest level of achievement. So what you're seeing here is a product that has earned the Cradle-to-Cradle certified silver mark. It's nice to know from this scorecard that they have excelled on the renewable energy and the social fairness criteria, but since their lowest level of achievement is silver, that is the level that they put on their product. We have been asked now, in the past, this scorecard information has been optional for manufacturers to post. We've been asked by the U.S. Green Building Council, because Cradle to Cradle has been included in a new material health credit, we've been asked to report these scores. So we're making it optional for manufacturers to do that. So I think you'll see more and more on our website and our product registry the full scorecard for these products, but it will be manufacturers opting into that. And then we are changing our search function, so you'll be able to search by material health score to be able to apply for those credits. Not sure how many of our participants today are relevant to the built environment, but just wanted to mention that. And just quickly, kind of players in the certification process, how this works is a manufacturer will express interest in being certified, and they'll come to the Institute, and the Institute will give them an overview of the program, really help them understand what they're committing to, and provide them a list of accredited assessors. Then the manufacturer works with their suppliers and the assessors to start to compile the product information that's needed. Then the accredited assessor goes through the assessment process and ultimately presents the final packet to the Institute for review. Just a moment on accredited assessors. This is really about, so these are currently trained accredited assessors. There are more being trained later this year, so we really want to grow this group of folks to help scale the certification effort. And the Institute's role here is really is quality control. We train and accredit the assessors. We verify the assessments reports that come to us. We issue the certifications. We do spot audits. And we have decertification authority should that be necessary. So what I want to do now is go into the certification methodology, and I'm going deep into the material health criteria first. If we have time, I will proceed to the other four. Otherwise, as I said, I'll just make that information available following, because I thought the material health might be of most interest to this group. So we start with our material health criteria. You can't do green design, of course, without green materials. And this has become a hot topic for building owners like Google and JLL and some large architects and design firms who have led initiatives sort of requesting more transparency for manufacturers to get at this very issue. And this is where I think cradle-to-cradle certification can be a quick reference guide for benchmarking material health for those kinds of programs. The ideal here, what we're working towards in this material health criteria, is safe ingredients perpetually cycled. So how do we go about it? The first step is a bill of materials. And this is really just presenting it at the generic level, and at this point is really a self-declaration on the part of the manufacturer. With the bill of materials in hand, the assessor begins to contact the supply chain to understand the chemical formulations of each of the materials. And this can be challenging to get at this information from suppliers and, of course, their suppliers. These supply chains can be many layers deep. In some cases, there may be proprietary concerns, and in some cases, the manufacturer may just not know. Our assessors enter into non-disclosure agreements with suppliers to make sure that they can get detailed and accurate information. And this is where this program may differ from some of the other programs out there that are sort of, looking for transparency. While we encourage transparency, we're realistic in understanding that sometimes this information cannot be gotten without NDA. So again, transparency is encouraged, but it is not required to become certified. The materials that are subject to review here. Each homogeneous material presented at the 100 parts per million in the overall product is subject to further review. There are some exceptions to that must be reported at any level, and those are listed here. Then the chemicals that are subject to review within those materials are those chemicals presented again at the 100 parts per million in each homogeneous material. And again, there are some exceptions here. Regardless of the concentration level, there are some things that have to be reported no matter what, and you can see some of those things here. Then we have a list of banned chemicals, and this applies to all certification levels. It applies to intentional inputs at the 1,000 parts per million, with the same exceptions applying. And we have two banned lists. One is a technological nutrient ban list, and this allows for use of some chemicals like lead and PTFE in materials where exposure is highly unlikely to occur, but those are not things that we would want to see in the biosphere, and so they are not allowed if they are in the biological nutrient cycle. Additional things that should not be in the biological sphere are those things I just mentioned. Those are part of the ban list, and here is a list of the ban list chemicals or chemical categories. And once the chemical ingredient list is complete from the assessor scans for these ban list chemicals, and a product, if it contains any of these, cannot be certified at any level. This ban list is dramatically expanded from our version 2 protocol, which just covered the PVC and PVC-related compounds. And ban lists, admittedly are controversial, and they are for us internally as well. One of our founders, Michael Brongard, is a chemist, And this is the list that was developed and included in the standard that was turned over to us last year. The Certification Standards Board, now independent board, will develop a process for identifying and including chemicals on this list as we move forward in the future. So, just to give you a sense of that, I know ban lists just create more, sometimes can create more problems than they solve. So now, if a product passes if the material passes the ban list scan, then the assessor begins a full assessment of each material and every chemical within that material. Each chemical and material is given a green, yellow, or red, we call X-assessed, rating. The aspirational goal here is to ultimately have products that are only made of those green and yellow rated materials and to eliminate all red or X-assessed materials. So I'll give you a little brief on how we go through this process. Chemicals are assessed against 24 human and environmental endpoints. These are the human criteria that are included, and this is the environmental and sort of other criteria that are included. And then each single chemical is evaluated against those 24 human and environmental criteria. The chemicals are considered for hazards and then assessed for potential exposure throughout the life cycle. And examples of this would be like cancer risk due to incineration at the end of life. So it's a highly likely unintended use of the product at that stage. And what we do then is, or what the assessors do, is arrive at an overall single chemical risk assessment. The single chemical assessments are then rolled into a material level, and again, this is true for the chemical level as well as the material level. The lowest level of achievement is the end rating. So if in all of the single chemicals in that material there is one red or X assessed, then the whole material is red or X assessed. So a bit conservative. Then each material in the product is assessed for cyclability, and this again is reinforcing the importance of designing for cyclability, and based on its fate in likely post-consumer use. A green rating on cyclability would mean it is highly degradable as a biological nutrient or fully recyclable as a technical nutrient. A red rating would mean that it is not degradable or not recyclable. So not only can the chemical content give it a red or X-assessed score, but its ability to be cycled can also mean that it may not be an ideal ingredient. Finally, if the product contains recycled content, the recycled content will also be assessed against this criteria. And again, the goal, while recycled content is good, our goal is really safe materials perpetually cycled. So the outcome of a material assessment will look like this, and this is an example of nylon 6, which is a carpet fiber, and the human health portion will be complete. And what you're seeing here is the worst hazard score for each of these ingredients in the material. Then you're seeing the exposure and the ultimate rating for that. And this is one of the very few examples, and that's why I wanted to include it here, where we've got material, carbon black, that is red assessed for its hazard. But as it is included in this polymetric material, it doesn't pose, the assessor deemed that it does not pose any risk to the user or the recycler of the material, and so it is moved to a yellow score for exposure, allowing this product to be yellow overall. There's very few examples of that, but I wanted to provide one to bring that to life. So now that the material health assessment has been complete, where do we go from here? Well, we work with the suppliers. You can enter the program at 75% assessed, and this is really recognizing the difficulty in getting at that supply chain information. So you can enter at the bronze level in material health if you've been at least 75% assessed. The goal at gold is that you are 100% assessed and that you have no red chemicals in there. Manufacturers in the process commit to phasing out problematic chemicals, and they're working towards that 100% safe and healthy preferred chemicals. And then in the future, designing products with those preferred materials. And I wanted to do here, I won't go through each of these, but this will be included in the PDF available afterwards, give you a sense of what it means to be certified at each level. And of course, now you know no banned chemicals allowed in any level. You can enter the program being 75% assessed. At the silver level, you're 95% assessed, and at that level, there are no carcinogens, mutagens, or reproductive toxins in the product. At gold, you're 100% assessed, and of course, you have that all positive chemistry, all greens and yellows going on there. So I wanted to give you a sense for that. And I notice we do have a couple more minutes, so I'm going to go ahead and quickly take you through the other attributes, just to give you a sense of them very, very quickly, and you'll have additional follow-up information. But one last note on the material health attribute. I believe last month you had Mark Rossi present from Clean Production Action, and CPA has a chemical hazard screening protocol called Green Screen. And since the beginning of the year, we've undertaken an analysis with Clean Production Action and have found significant amount of alignment between our two programs. As a result, Green Screen full assessment data can contribute to the cradle-to-cradle material health assessment for that hazard portion. Our assessors will accept the data, which should help reduce time and cost of pursuing certification. So if you've engaged in Green Screen, you can use that information towards cradle-to-cradle. And as time goes on here, we'll continue to explore alignment opportunities to really lessen the burden on manufacturers and assessors who are going through the program. So I wanted to make mention of that and tie that back to your last webinar. Quickly here, our next attribute that we assess is material reutilization, and what we're really going for here is eliminating the concept of waste, designing everything to be a resource for something else. The goal is to have 100% recovery and upcycling of technical nutrients and having 100% compostability of those biological nutrients. So you're getting the idea that really designing to work within those cycles is important, and a real mindset change in product design. So how do we arrive at a material reutilization score? What we're looking for here is how recyclable or how compostable is the material, and then how much recycled or rapidly renewable content is used in the manufacturing of the material. And notice we value the reusability twice as much as the use of recycled content, and again, stressing the design for reutilization. So I provide the summary table. Actually, that's a little bit of a repeat from the slide before, so you can get a sense as you move up your material reutilization. What we're doing in the end is that the product is actively being recovered and cycled 100%. The next attribute is renewable energy. And remember, if we move towards the vision of 100% renewably powered, we really change the conversation around the carbon footprint. And for this criteria, companies really need to take a deep dive into understanding their energy use. What kind of energy are they pulling off the grid? How much energy are they using in their entire operation? And make a plan to move towards 100% renewable energy. And this, I think, is probably one of the most challenging additions to version 3. While renewable energy has always been included, these cutoffs here are much higher. So you'll see at the bronze level, at the entry level here, you're just really looking at putting a strategy in place, understanding your usage and putting a strategy in place. At the silver level, you're offsetting or using 5% renewable. And at the gold level, you're up to 50% renewable and offset for electricity and direct on-site emissions. That is a big bar to achieve, especially depending on the kind of manufacturing facility that you are. And then, of course, at the highest level, looking to be 100% plus renewably powered or offset. So high bars there. In water stewardship, this is really changing the way companies interact with water and requires a fundamental shift in thinking about a resource that's traditionally been viewed as cheap and plentiful. At the platinum level, what we're going for is that water leaving the facility is cleaner than the water coming in. And just to give you a sense of what companies go through here for the achievement levels, again, first knowing, really understanding what their water usage is, what they're pulling off of, and what chemicals may be included in there. And there are different options here depending on if you are a manufacturing facility that produces effluent or if you are a dry manufacturing facility, and then you start to look at water issues within your supply chain. So that's how you progress through those levels of achievement. Social fairness. Cradle to Cradle is about regenerative cycles, and the human aspect of that is paramount because it really matters how things are made. The goal here is to become a partner to all stakeholders in the process. And what we're looking for here is really moving through first a self-awareness, do a self-audit on these socially responsible issues, put together a management plan, then do a more in-depth full audit, and then move towards a third-party audit. And you'll see there's different levels of achievement here, and as you move up, you're completing more and more of those tasks, and ultimately becoming a partner to the communities and the regions in which the company operates. Unlike labels that are one-time certifications, Cradle-to-Cradle manufacturers make an ongoing commitment to continuous improvement. And what this means is that the company is making a good faith effort towards optimization in all 5 categories. They outline intentions and strategies to achieve positive impacts. They prioritize the phase-out of problematic product inputs and strive for higher levels of certification, and of course are recertified every 2 years. So having run through that very quickly, what I'm hoping you'll take away is that Cradle to Cradle is an independent, transparent, third-party program. It's a rigorous multi-attribute assessment. We focus on continuous improvement, and hopefully all of this information can be used as a reference tool to help specifiers and consumers select better products. So with that, I'd like to open it up to questions.
Stacy. Oh, I guess I just got unmuted. Thank you so much, Stacy. Interesting, and I'm really glad that you did have the opportunity to put your additional slides up. We do have a question to lead off, and I'm hoping that we will get some more questions as we go along. And please don't wait till the last minute. There's, another 20 minutes left for questions and comments, and I will hope that everyone will take advantage of that. So the first question is somebody saying, I'm interested in the water standard. If you are able to focus on that, and then in quote, second, thank you.
Okay, so what we're looking for here, and I did go through this awfully quickly, and there's more information on our website, is what we're looking for here is for companies to really understand first their water usage. So what we're going to do is have you make sure that you haven't, there's of course have been no violations in the past 2 years, but then really understand what the water situation, are you in a drought environment, where is your water coming from, and starting to mitigate any problems there. You'll be testing your effluent, characterizing what's in that, perhaps putting in a water recycling program if you're a wet facility, if that's appropriate for you, and starting to really clean up the these things work together, right? If you're cleaning up your chemistry, you'll be cleaning up your water output as well. I think one of the best examples of this is a company called Design Tex. They make a textile fabric, and when they set out to design a biological technical nutrient that could be fully compostable, and in looking into that, they had to assess or kind of evaluate 8,000 chemicals that are commonly used in textiles and fabrics, right? And there's the dyes, there's these chemicals that help increase performance of the fabric, all of those good things. And they took that down to 16 chemicals that met the cradle-to-cradle requirements and did their entire line with those chemicals. After they started manufacturing this process, the regulators came in to test their water, as was an annual event for them, and the regulators were astounded to learn that the water coming out of the facility was cleaner than the drinking water coming in. So it's a great example of sort of clean ingredients out, clean ingredients in, clean ingredients out. If that, I hope that helped, and if not, please ask another question and I'll try to elaborate.
Well, we have several more questions, and this one is a follow-up to the one that you just got, which is how do you treat quote-unquote non-toxic items like phosphorus that are natural but are in large quantities, present a major problem in the environment?
This is a great question, and this is where we should have started out in the introduction saying I'm not the chemist. So some of these specific questions, what I would like to do is maybe follow up with you afterwards and get our senior scientist involved who would be able to provide a better answer for that. So I apologize.
That's great. That's fine. I interpret the question a little differently, though, not as a chemistry question per se. It's just interesting. I was just at a meeting yesterday in which there was a lot of discussion of phosphorus and the impact it's having on the Great Lakes. And I may be not interpreting the question correctly, and certainly correct me if I'm wrong, but I think the question is how does the tool, how does the, the matrix that you have, how does it deal with items that are not listed on banned chemical lists or are not considered toxic, let's say man-made chemicals, although they often come out of man-made chemicals. But there are large influxes of phosphorus into the Great Lakes, for example. And how would you address that in your, when somebody engaged you to undergo the process with you, how do those kinds of chemicals and substances fit in?
And so, Lynn, I appreciate that kind of elaboration on that. And what I'm thinking is that because there is known environmental impact from something like that, that as the process chemicals in the effluent are analyzed and optimized, that issue would be identified as an environmental problem and be slated for optimization. Although I don't have an example of that.
Well, I think that's more helpful, actually.
Okay.
So the next question is, how would you describe your process versus the GRI? And I hope you know what GRI is.
Global Reporting Initiative, I think.
Okay.
And you know what, I'm not as, I would need a moment to gather on GRI real quick, just to, Global Reporting Initiative, one sec.
Well, why don't we move on to the next question, and then you can always follow up with us on that particular.
That would be great.
So the next question is, how will the third-party independent claim for the standard be maintained if one of the assessors also works for MDBC, which does a lot of certification application work for its clients?
Okay. Yeah, I think I can clarify that one. MBDC, right, was the body holding the certification standard and issuing certifications in the past. And now that standard has been turned over to the Institute manages the standard and issues the certification. So MBDC is now an accredited assessor. And so all of their packets and work is submitted to the Institute for review and subject to auditing.
Okay, I think the question was, essentially how do you avoid a conflict of interest? And so are you saying that there is a sort of a firewall between, in that regard, between DBC and the Institute, so that you don't have crossover of people who work for both MDBC? I think, the issue is, if you have people who were, how do you avoid bias and conflict of interest, I guess is.
Absolutely, and we are two separate organizations now. MBDC is located in Charlottesville, Virginia. We are located in San Francisco. So we have no overlap of employees there. And MBDC is treated like any other assessor that has been trained, and so there's no overlap of work or Yeah, 2 independent organizations.
Okay.
That's a very important part of the change that was made 2 years ago and why the Institute was started as a nonprofit. We really had to get the standard to stand on its own in an independent organization. We thought it was important that that was a nonprofit organization.
Mm-hmm. Great. I think that's the answer we were interested in.
Good. I'm glad that you clarified that because it is such an important part of the change that's happened.
So the next question is, in the material health section, how do you determine whether a chemical ingredient is associated with exposure? Do you consider occupational exposures and or an end-of-life dispersal to the environment? In particular, how did you assess that with carbon black in your example?
Okay, and this is a question for an assessor, but I can say that a lot of judgment is involved in this exposure part, but it is exposure throughout the life cycle of the chemical. So they're looking at exposure in manufacture, use, and disposal of that, but there is a lot of judgment that's used on the assessor's part, and over time the Certification Standards Board and working in conjunction with other kind of thought leaders in this area would like to bring some more structure to that.
Okay. So, okay.
And so, yeah, so I can't specifically, what I can do is go back and you can see the write-up that the assessor included for that carbon black as the explanation, but again, here we go. So what they're saying is that in the polymetric material, it does not pose a risk to the recycler, to the user or the recycler. And this is right, carbon black is used in, right, your black computer has carbon black in it, your Polycom, if you're on the conference call, right, all those things have the carbon black in it. Now, what they're saying is now, so that it's not available in the biosphere to be absorbed or inhaled, which would be problematic. If carbon black were available in those forms, that would not be allowed to be made yellow.
So I think the question is, looking at this, what I then wonder is, it says that it poses a risk to the user or recycler of the material. And it's not clear, I think, who the user is. That would be helpful to have a sort of a more precise definition of the user, because the user could very well be referring to the consumer in this case, and it doesn't address, at least in the note that that you've got there, whether the occupational exposure is considered in that process. So I do understand that you're saying it is throughout the life cycle, but it's
not clear from this note. Yes, yeah.
And often the occupational aspect is not included in the life cycle assessment. So.
Mm-hmm. That is something I can follow up with the assessors on.
Okay, that's great. Thank you. I do think that's a really, really important issue, though, that I think we would be really interested, in finding out more about.
You've given me time between questions to come back to the GRI, the Global Reporting Initiative, and there is it's not detailed here in my slide on the social fairness, but there's great overlap in what the reporting is needed for the social fairness and the GRI. So if a company is doing that kind of work, they've done a lot of work already towards the social fairness criteria there. So sorry, I just had to get my brain clicked into that, but that's where it would show up in the social fairness work.
Okay, thank you. Certifying by product may be tough due to cost and complexity. Are there any plans to certify by company level where focus is manufacturing KPI, but product portfolio materials could be assessed by plant use, that is 50 to 75% for the low bar facility, wide, regardless of product specific. This would cause a shift in overall product portfolio, and I think this might gain more traction to engage more companies.
That is an interesting question, and I actually, Lynn, it was very common. Do you want to try to break that one down, or let me open the questions box so I can review that in.
Sure.
Oh, the questions are not showing up in my box, so.
Well, starting from the beginning, it says because certifying a product that certifying a product may be tough due to cost and complexity. So, considering that, are there any plans to certify by company level? And I'm not sure what the questioner means by company level, where focus is manufacturing KPI, but product portfolio materials could be assessed by plant use. In other words, not in the product itself, I think is what I'm understanding, but use in the product, in the manufacturing of the product itself.
What I can speak to on that, and thank you for repeating that, I appreciate, what I can speak to is,
so the questioner should definitely correct me if I did not, portray that correctly, because what they're asking is that it's sort of, as opposed to being product specific, it's looking more at the manufacturing process itself, plant wide. And he or she is saying that, I think it's he is saying that this would, if you did it this way, this would cause a shift across products and might be able to gain more traction to engage more companies.
Yes, and what this has me thinking of is in the built environment where I specialize, we're starting with the product, right, and we're going backwards, and it's so hard to go down the supply chain. In other industries like textiles, we're starting with the basic building blocks of those things, so that many designers can then pull off certified building blocks and ultimately, I think, achieve what the question is being asked here, make it easier to design and manufacture products that will be certified in the end. So getting more building blocks certified, getting more chemicals and materials certified versus end products would certainly transform the industry. And I think in other industries like consumer products and textiles, we have a better chance at that right now than we do in the built environment, but I'm hoping that will change.
Okay, the next question is MBDC has a large database of material assessments from previous work. Do the rest of the accredited assessors have access to this data, these data?
Oh, that's a great question. And this idea of, so yes, EPEA, APEA in Europe, they have an enormous database of their own proprietary work. Tax Services, you may be familiar with in Washington, D.C., they have a database of their proprietary work. We're exploring, in conjunction with other industries and with the USGBC and Healthy Building Network right now, would there be a possibility for a shared hazard database? Would there be incentives? Could a quality program be put in place? And I'm sure that your constituents that are participating in this group are asking the same thing, and there's a lot of initiatives out there. It would be ideal to have a larger database. It would certainly increase the speed of assessments and reduce the cost, so that assessors aren't doing the same work over and over again. So no, each group has their own proprietary database at the moment, and their sort of reputation, their ability to be cost effective, I think, depends on the quality and size of their data.
Yeah, I would assume that that's also an issue of competitive advantage to some extent, based on the size of your database. But it's interesting. I don't know. I mean, obviously, I can't speak for these assessors, but there's a lot of discussion that goes on in a different context within the Green Chemistry and Commerce Council of sharing of data, and I'm wondering whether what's the most advantageous to accomplishing the results, and is it at all dependent on a shared database or just the proprietary databases? So. Okay, well, actually, that brings us right up to the hour practically, and I really want to thank you again, Stacy, for joining us this afternoon and informing us about the work that's being done by the Innovations Institute, the Cradle to Cradle Innovations Institute, and I should say Products Innovation Institute, excuse me. We certainly appreciate all the people that joined us this afternoon, and thank you for all your great questions. You can always email us or go to our website, but you can always email either Clinton or me, and the email addresses on the websites are currently up on your screen. If you would like more information, if you would like us to contact Stacy, and also let me encourage you as well, if you have ideas of people that you would like to hear from in these webinars, by all means let me know, because I am really interested in scheduling speakers that are of interest to the folks on the call. And we've been very lucky and very good at getting a wide range of speakers. So please be sure to let us know about that. Again, I hope that we will have you back again next month on August the 14th. And thank you again for your participation this afternoon.
Thanks, Lynn.
Thank you.